So let's get into some basic how-to stuff. Oh, character encoding. How I despise you. So character encoding. Text can be represented in different ways in digital format. This happens because texts are rendered on different web pages in different points of time in different countries. And so different systems of alphabets are used to keep track of what a character is. So for example, if you've ever scraped data from a website and all of a sudden start seeing a bunch of funky, weird-looking characters, who's seen this scraped data from website before? Right? It's a pretty common experience because you may be coercing one character encoding into another. And when you do that, whatever character encoding you're putting that data into is taking a wild guess about what that character can understand. So for example, if you have like a French accent aigu on a text, right, and then the character encoding you're using doesn't recognize the accent aigu, it will show up as a strange character. And this is, there are dozens and dozens of types of character encoding as more and more languages come online. And again, as changes are made over time, language like Chinese, multiple variants, Pinyin, and so on and so forth. There's a lot of these character encoding out there, and often, particularly for scraping data from multiple sources, we'll wind up with different types of character encoding, and this will wreak havoc on a lot of the methods we're talking about today. There's a variety of ways to try to get at this problem. There's a utility function in R called iconv that can be used to change character encoding from one type of character encoding, for example, UTF-8 to ASCII or something like that. And this is just important for those of you who are new to text analysis to understand that if you don't have a uniform character encoding, you may be creating weird words in your data set, or certain entire words might not be viewed at all. So be aware of character encoding. There are some techniques that are designed to try to automatically detect the character encoding. In my experience, they kind of work. I've had mixed results with them. Has anybody have a good tool to detect character encoding? Okay, so
what's the name of the tool?
iconv. It's a function in R, yeah.
Oh, okay.
I think Hadley Wickham has written a guess character encoding function, but I'm not sure.
There's a similar one in the Stringer package.
Stringer package, yeah. Cool, thanks. Will you throw that in Slack, please? Thank you. Second, what counts as a unit of analysis? This is the process of tokenization. So are we thinking about sentences? Are we thinking about words? Are we thinking about entire documents as a unit of analysis? Are we talking about sequences of words? N-grams, meaning one word or a sequence of 2 words or a sequence of 3 words or 4 or 5. These are decisions we need to make in the process of transforming words into numbers. We need to decide what our unit of analysis is going to be. Typically, it's a word in most applications. There's some reasons why using different lengths of sequences can be interesting if you're out to capture meaning, which we'll talk about right before lunch. Okay, questions on any of that? No? So typically, we face a number of additional decisions when we're trying to get from that messy trunk transcript to a neat matrix where it's populated by, say, zeros and ones that describe some theme, okay? The first is punctuation marks. What do we do with them? Do they add meaning to a text? Almost certainly, if we're saying that a punctuation mark is helping us understand how to read a sentence, right? And as we see here, different punctuation marks are used with different frequency. And we could talk about the absence of possessive nouns is clouding the meaning of a text. But by and large, it's common practice to remove punctuation marks from text before analysis. There are some papers that have looked at the effect of removing punctuation, one by John Moore and Robin Wagner-Cificci. That paper's not out yet, but it's making the claim that there's some serious bias introduced. That's the first time I've seen any evidence of that. Again, I think it's pretty commonplace to remove it, but maybe it's worth checking out the article. Yeah?
I could imagine that for certain types of analyses, studying the punctuation might be the most useful thing. Like the thing you had up earlier about the Trump and Associated Press dialogue.
Sure.
That's one of the things that's most characteristic of Trump is not the words he uses, but the way he says
Sure, sure. There's that, and then there's also the tokenization, right? Are we tokenizing a sentence by Trump, a sentence by the interviewer, a sentence by Trump, a sentence by the interviewer, right? These are all things that you can see already there's some complexity and kind of vexing decisions that need to be made. And again, a multivocal text like that poses additional challenges than one that's got a single voice. And here's another example where, the comma profoundly changes the meaning, at least to us, right? The thought experiment, as we'll see, is when we begin to treat text as bags of words and look at text independent of word order, we often think it's a safe assumption. Second word case, capital G, lowercase g, God. Does this say something about the author of the text, right? A religious person might use the capital G. A non-religious person might use lowercase g, right? And if we're out, for example, to do analysis of the amount of, religious opinion expressed in a text, or trying to identify the religious affiliation of a person given a text, that might be a case where we really care about this. On the other hand, if we are doing a broader study of the amount of news coverage about religion, we probably don't care. So again, a lot of these pre-processing texts could be text-specific. It depends often how deeply you want to get into the context-specific nature of a text. And some of those back-and-forth methods of combining qualitative and quantitative tools in an iterative fashion could probably help you make these decisions. But again, all these decisions bear upon the overall research question. Finally, numbers. Many people drop numbers in analysis. Certain numbers have meanings. Once again, you could argue that this creates might cause you to miss some meaning in text. But hypothetically, we can treat a number just like we treat a text. It's after all just a string that we can then put into a bag of words if we so choose. So it's another decision we make. Finally, often we don't care about the, we want to capture the root meaning of a word like consign or consignment, right? Or run and running. Let's say we're out to measure how many texts are about exercise, like Given's work, right? Did you use a stemmer to look at running, right? He wants to treat the word running and the word run the same in order to not confuse them as having different meanings. They do have different meanings, obviously, in terms of what they're describing, but that also creates a challenge for a dumb computer, right? Are these things that are really different or a little bit different? The computer's not making that judgment. We could probably think about interesting ways to build that into some of our models, but it's commonplace to use a process such as stemming to transform each word into its constitutive or root form. One of the techniques I'll talk about before lunch uses a related technique known as lemmatization, which takes advantage of some more sophisticated syntactic relationships between words, but does a very similar thing. Okay, text preprocessing.